Okay. Copy link, done. All right. Hello. Today's lesson will be about mocking and testability. What is needed? What are mocks and what do we need to test basically anything that we have in our code? There's nothing untestable if you design it well. Literally nothing. The structure of this lesson will be that first I'll just draw examples of how you can mock something, and then we'll go into a piece of code that kind of simulates real code that is complex logic, and how do you test complex logic with simple test, and how do you make the test to act as documentation. Before we talk about that, let's talk about two types of testing. The first type of testing is black box testing, and that just simply means we feed input into some system, into some method, and we get output back. Input, output, and we check the result. Testing, so you pass input, you get output, and that's basically black box testing. An example of that is calculator. You feed two values and you get some back. White box testing is a kind of testing when you want to know what happened in between for critical steps, such as let's say your work pays you money, right? And it's not only important that they paid you money, but it's also important that you know that they notified you about it. In that case, you should check not only that your balance was with that extra money, but also that a notification was sent to you. White box testing, the word comes that it's important what happens inside. We check the method as if we passed it through an X-ray. That's the analogy. To perform white box testing, we need a mock. And a mock is just an object which allows us to override method's behavior. We need mocks because there is no other way to verify if something was called. Well, actually there are, but just all other alternatives are less than optimal and results in a lot of excessive code for no good reason. Mocks are used for overriding behavior of our components. Stubs, you could say stubs are kind of mocks that only return hard-coded values. Stubs and mocks are fakes or doubles because they shadow actual components, they override their behavior. For stubs, it's just for returning values. Stub by itself can be made manually, it's up to you. You can implement something and just override, and in the implementation just have the logic you want. For example, return always the same values, the same containers on a ship. That will be your stub, ship stub. With mock, you can do it programmatically without creating a class, and with stub, you can either use a mock and program it, or you can create your own class. Anyways, how do you mock with MockQ? MockQ has a quite nice guide of how to do that, a quick start guide, and it has pretty much all the examples you would like. And in any case, the most common uses of MoQ, actually all uses of MoQ, involve three things. Sometimes we just want to pass a fake dependency. We don't care what it does. We just want to get rid of it. In that case, we can just say mock off and pass the dependency. In other cases, we want to override the behavior of that dependency, set it up the way we want. And such example is people's repository mock. So we create a new mock of people's repository and we set up the repository so that we can getting people returns an empty list of people. Now, if we called people's repository without setting it up, it would result in returning a default value of people, which is null, which is not what we want. Therefore, we need, if we don't want no reference exception or something similar, we need to set it up. Soot by convention means system under test. So system under test is soot, and in many cases for the system that is being interacted with, that will be called, just abbreviated as soot, system under test. SUT because, well, it makes sense. For me, I personally don't like shadowing names like that, so I call it the way it is. I call it what it is. If I'm testing people's repository, I'll call it people's repository. If I tested some system, I'll call it system. If I tested something else, I'll call it something else, but I will not call it SUT because I think that is not very clear. Next. So far we have two use cases for MoQ, for generating fake dependencies, for programmatically setting up those dependencies, and last one is we can also use it for verifying if the right behavior was called. And that last bit is absolutely essential for white box testing. If we want to check if something was called, we need to verify it. And in this example, we verify if repo get, if get method of repository was called once. There are two things to keep in mind for MoQ. First one, virtual methods are the only methods that can be mocked. You cannot mock normal classes. You cannot mock anything else. A method needs to be virtual. Virtual method means that it can be either an interface, abstract class, or a method needs to have virtual keyword. Out of those three, the best option is an interface. And if you just create a new mock, it just turns off all the implementation that the method had, and it returns default values if it returns anything. It creates basically an empty method with default return values. Don't create interfaces just for making mocks. When you start having the realization that an interface is what makes your code testable, you shouldn't just add them for the sake of testability. It needs to make sense first, and then you should write it. Sometimes we split stuff in too much detail. And this balance between having interfaces and not having them is quite a difficult one to discover. To me personally, the ratio of how much code which carries logic and is not a model should have behavior, to me, that is around, I'd say, 95% of code. That is a big percent. But some people just go completely crazy and make that 100%, which disrupts the proper code design. Don't be over zealous about using interfaces for everything. Use them, just don't abuse them. Before moving to testability section, I'd also like to add, why do we need mocks? Mocks cut behavior off, right? And that means that something that previously could have taken a long time now takes no time at all, and it just ends the method immediately, returning default value. Mocks make tests run really fast, and with mocks we can test a single thing without getting other dependencies involved. Those are the two benefits of mocks. Let's move on to testability. First, let's look at code that is not really testable. Could you please tell me what's wrong with this code? What problems does it have? I'll give you 1 minute for that. Royalov said that it has dependency on an invoice class, and it's true, it has it, but that's not a problem, because as I mentioned, invoice is just a model. Invoice is just a model, and so it's not a problem to have it as a dependency, because it doesn't really provide the behavior, any behavior, it's just something that will be sent. An invoice will be sent, but by itself it does nothing. And the biggest problem here, the first problem here, is actually this chunk of code. Imagine, so okay, next question. If you are to test code for paying salary, and paying salary says that, well, your code should um, um, pay the salary after taxes and notify employee. So what do you think, what needs to be tested if there are those two requirements? And which part of code does not represent that requirement of paying, of getting salary after taxes and sending a notification to the person, to the employee? Any answers? When you think about dependencies, you should so when I talked about paying salary requirement, I talked about two requirements. But if you look at this code as a whole, there's more than two things that happen here. This part that picks tax multiplier based on person age and salary is a bit that doesn't really belong to paying salary. You want to call something that picks those for you. You shouldn't care how that is being performed. You just get the tax you need and apply it and then pay it to the person. You shouldn't care about how that's done. You just get it. And right now, as of now, this part is inside this method. So this is a sign that it should go outside. And of course, legacy email sender is a problem because it's another dependency. But by itself, this thing is much worse. Hard dependency, that's there. Slow because we send email and we don't know how long that takes. Of course, side effects. Anyways, how do we fix that? And back to the concerns. All we want is to pay taxes, pay salary after taxes, and notify employee after about the payment. What does not belong? It's taxes. It's picking taxes. How do we make code testable? We keep it small, simple, inject dependencies, and don't hard code business critical things. What does that mean? That means that our tax picking logic should go into a class of its own. So we extracted that logic into government class, and government class provides us with the taxes multiplier. And now paying salary is not a concern. Like, it does not concern itself by having the complex logic of picking the taxes. Government provides us with taxes, as in real life. However, we still have a problem of hard dependencies. The problem that we solve here is single responsibility. Now we can test getting taxes in isolation, but we still basically invoke the same thing that we already tested when performing payment of salary, paying salary. As we mentioned, we could inject something as a dependency from outside. Jamie said, okay, but you just extracted the logic in another method. Fine, this may be more readable, but it wasn't a problem for testing. That's true, but you'll see where I'm going. That's just the first step. First, you need to clean it up so that you don't do things that you shouldn't be doing. And workplace shouldn't concern itself with picking the taxes. It should just call government, which does that for it. And you'll see why does that matter in testability and how does that help with tests. Here we inject the two dependencies that are responsible for both notifications and taxes picking. And now paying salary is left just by itself to do all that it should and nothing more. If we look back at email sender, well, the problem with email sender was that it wasn't interfaced, and we also had to do something about it. Legacy email sender does not support iEmail sender interface, and also the problem with this is that it's some old code of a lost code base, and we only have source code. Well, not source code, but compiled DLLs that we cannot change. So what do we do about that? How do we work with a dependency that doesn't have an interface, but yet we want to somehow escape it? How do we escape legacy code that we really are afraid to change? And the answer is, well, if we cannot touch it, we will try to adopt it, hide it, and wrap it. And the answer to this is an adapter. So if I create a class adapted email sender, which now can derive from whatever interface we want because it's our class, and supply it with the legacy email sender, we can now have basically the same legacy logic, but under the interface that we want. And adapter is the thing that you will be using all the time when working with third-party code that you want to properly adopt into your system. If we want to, for third-party components or for legacy code, work the way we want, we will need to adopt it into the system and put it under the interface that we want. Now that we have this scenario and that all the dependencies are injected, we can perform testing finally. So the first thing in testing is having a proper setup. And this setup means that we create mocks for email sender and for taxes picker. Going back, if I didn't extract taxes picker into a class of its own, then I would need to test taxes picking logic along with notification sending logic, and well, along with verifying that a person was notified and that their balance had funds added to it. If I don't split it, I will have redundant checks because there are at least 3 conditions how taxes change based on people. First condition, what if person is under 18? They don't get taxed, but if they get more than minimum salary, they do get taxed. What if they are over 18 and have that more than minimum salary? And then what if they are under 18 but don't have minimum salary as well? Like, if you combine all those cases, actually that's 4 cases, you start getting quite many different combinations. I still need to test that logic, that is a good point, but no longer in combination with other logic. Now it's isolated. And now when I'm testing workplaces, pay salary method, I am no longer interacting with taxes picking logic or with how notification gets sent, because that is in my control. And that is the benefit of mocks. You cut out the things that are not needed to be called and that could potentially affect the test, though they should not. It would be quite hard for me to test how much money was added if how much money was added is done somewhere internally and I depend on that. My public interface is not changed, actually. I just have more interfaces. So granularity is something that you want in your system. You want to understand what it does, and you don't want things to be hidden when they shouldn't be hidden. If you want to test a part of logic, and that part of logic is nested somewhere or is private, you should consider if that logic shouldn't be made public. Anyways, another important part here is that we have two build methods for building workplace and building person. Those methods basically mean that in order to test workplace, we don't really care about neither what sends email nor what picks taxes, and therefore in build workplace method we don't pass anything as arguments. We just build workplace so that we can interact with it. What goes in it is not really that important, so we don't show it in the build method. And same for person. We don't care how much they earn, what their email is, what their name or age is. We'll just check that they got the salary they needed and it was sent to the right email. How does that look like? Final test that is self-documenting code looks like this. Absolutely zero noise and just verifying the info that is needed based on the requirements. Remember the requirements? It says that paying salary means adding that salary to the balance of employee after taxes and notifying the person that it happened, that they were paid. First step, create workplace so that we can pay salary with, and create persons so that we have something to pay salary to. Now that we have our system and our input, we can act with it. Workplace pays salary to person, and we verify the requirements. What salary should be paid? Well, it's salary after taxes, which is salary multiplied from dummy taxes. And in the end, we just assert whether the expected salary was equal to this to the balance that the person now has in his balance. And we also verify if there was a email sent. It doesn't matter with what content, that's not our requirements, we don't care, but we care to whom we send the email. So we check if the recipient also matches matches the person to whom it was sent. And like this, you have a fully covered 100% tested method, and it's actually even impossible to fail that method because it's perfectly tested. If I didn't split the logic for picking taxes, in my assert statement, I would also need to include asserts and turn this fact into theory and pass different people with different age and salary, and assert on top of asserting those two things, assert if the right taxation was picked based on the people. That is none of my concern, and therefore I shouldn't care. If you read the test now, the test name, the test case name, it 100% represents what was tested. And if we read it again, it says pay, that's what we call. And what happens after you pay? Adds pay after taxes to balance, that's our first assert, and notifies the person, and that's our second assert. Name of a test should represent what it does. Name of a test, just the label itself, should describe how our system behaves. Otherwise, it loses the point of being self-documenting code. That's all for theory for this time. And I have a lot of code that I wanted to show, and a few interesting parts actually. I'm not sure if this will work, but I think it will. Let's try to run it. Yeah, so the test lighted green, it means it's working, so all is good. Also, one quick fix, it should have been not build person, but build person with 0. Actually, it's fine. Build person is fine. Never mind. I wanted to add with 0 balance, but then it would, you would start questioning, does balance being 0 matter? What happens if balance is not 0? Do I get less money? Do I get more money? Remove the noise, remove the questions. Looking at this test method, there are no more questions. It's crystal clear how it works. You, you, you cannot ask anything because there is nothing to ask. It's just trivial. Anyways, do you have any questions from mocking topic or testability? We'll delve deeper into testability when we cover solid. Solid is a collection of best practices, and it's hard to talk about testability without knowing solid, but it's good to know at least a few principles how we can improve it. Anyways, if you have no questions, I would appreciate if you would tell one thing that you think you understood very well and one thing that you would like to understand better. And based on that, we'll try to delve it in live coding part. Roloff asked, is it wise to place the code to make a workplace and a person in the test instead of a separate method? If I placed this code in the test method, we can actually make that and compare the results. Now let's say this doesn't exist and we look at this code. If I look at this code as a reader who just tries to understand how the system works, I start reading and I read it like this. So I create a workplace by passing those two things. And then I create a person by giving it name Tom, and I'm thinking, does name matter? Age is 18. Does age matter? Salary is 600. Where does that 600 come from? Email is dummy at man. What the hell is that email? Should I validate it? And account is dummy with balance 0. What if it's negative balance? Can we send salary then? I start asking questions. When I see all those details, questions come to my head. Technically, it behaves exactly the same, but from documentation point of view, now I start asking questions that I don't really need to ask. And that's not really my intention. If I don't need to ask questions, then it should be like this. Here, I remove the things that could potentially cause questions and keep it clean. That's good. That's very good. I think a few months ago, I also had this thing where I wouldn't create a method for that, those builder methods. But after reading book, which I highly recommend, it's called XUnit Testing Patterns. They highly praised such technique, and it's really something that I agree with. It does make a lot of sense. Right. Also, you might wonder why build and not create. What's the difference between building and creating? To me, build is something that happens once, and create is something that happens multiple times, and you can create different things. You build one thing, but you can create different things. Factories create different objects. Builders build a single kind of object. That is the distinction that I tried to make, and therefore it's build and not create. Now that we have established that, let's delve into some more interesting cases. Imagine you have a simulation class. What happens if, well, I already exposed this, but imagine that you're testing something like this. Imagine you're testing something like this. A weather generator, weather simulator, which generates weather at random. And it generates it based on probabilities you pass it. So my simulation has basically three weathers: sunny, rainy, and cloudy. And if weather is bad, well, if a certain probability is given, a certain weather is picked. And the way it works, basically, highest probability is, well, not highest, but first probability is for sunny weather. It basically means, let's say it's 1%. So it means that in order to be sun, for example, if it was 1%, it needs to be randomized as 99 and higher. So that is just 1% chance. So if it was 1%, it needs to be 99 or higher. That's how it reads. If it's rainy, it needs to roll in between 99 and 99 minus rain probability. And if it's not that, by default, it's cloudy. That's how this probability thingy works. How would you test it? It's random, and it depends on random. And how do you get in control of random? How can you go in control? How can you be in control of random? Can someone explain me? How do you go in full control of random? There are actually 3 ways how you can go around this issue. 4, actually. Anyone? How do you test something that's random when you actually want to be in control so you can properly test it? Seed is one answer, but how do we pass a seed? Our random is hard coded right now. And that would also, if we are injecting a seed in our simulator, that would work. If we know the seed, we get the same sequence of random numbers. However, we still need to run it, test it, see the random sequence, remember it, hard code it, and test it based on that, which complicates things. And the easier way is to just, again, do the same thing we did with our legacy thingy. Wrap it and swap it under an interface. And I did that. Here is the interface. Here is the interface. iRandomizer, so iRandomizer can give us a random number. That's neat. That's all. And with iRandomizer, we can now test weather generator. Let's test it. Let's test it thoroughly. So we create a test suite, and the name of test suite always represents the class that you test, and you just append suffix it with tests. What do we test? We test that we can actually test it in many different ways. But let's first test with a mock. I'll show you different tricks that how you can work around the issue. So first, weather generated tests. Void. What do we test? Generate weather when, or more like given, rainy chance, returns rainy. How does that work? Let's create a system. I'll first just make it work and then refactor it, clean it up later. So we create weather generator. Weather simulator, okay. Simulator with probabilities for one and the other, and randomizer. Our randomizer will look like this. And we need to set it up somehow. I'll put it to do because I need to figure out how. And we create our guy simulator from this, and probabilities I put 0 for now because I need to figure out what we need. And what do? We say simulator generate weather, and we get weather, and we assert based on our test name that we expected rainy, and we got actually this thing. Now we need to compare them somehow. So we need to simulate that we got proper weather. The easiest way to simulate that rain happened is by making its probability 100. So it's impossible that it doesn't happen. And like this, we actually don't even need anything. we can just say we can just do this and say this is 0. And yeah, so fact, if we run this, our weather function worked. If you don't believe me, I'll debug. And you'll see that sometimes there are even ways how you don't have to mock it all the time. You can just work around the issue in different ways, and ways that are not dead end. Where's my continue statement? What the hell? Okay, anyways. Let's make this a theory. I wouldn't write any other tests. That's all that there is to test that my RNG logic works. Actually, there is quite a lot of logic. See this logic, this logic. That's decent amount of logic. It's not empty logic. It all makes sense. I would probably add logic here. So you see, I have logic for constructor. Basically, if I pass probabilities, they mustn't exceed that. Anyways, if you're saying about this thing in particular, let me continue and just properly test the full method. Inline data. In order for us, what matters in this simulation? We now deducted that this doesn't really matter, and all that matters are those two probabilities, right? So let's design it so that we can test it properly. Yeah, I'll add more cases. So let's create weather simulator. Probability of rain, probability of sun. Even though it's just one thing that I shadow, which is randomizer, I'll do it. Come on. Okay, good. I'm a bit annoyed by the test window. Okay, we have that. Now we can call this by just passing those two thingies, 100 and that. And those two thingies are arguments given chance returns expected weather. And now the specific chance and expectation will be defined here. If we have 100% of rain, 0% of sun, our expectation is that it will rain. If we have 100%, 0% of rain, 100% of sun, what's our expectation? Sun. And last one, if we have 0% of rain, 0% of sun, our expectation is that it will be cloudy. And now we need to just feed those parameters here. weather, expected weather. And now it just makes sense. Probability of rain, probability of sun, generate weather. What do we expect? We expect expected. What do we get? We get actual. Let's run it. And it failed. It failed in 2 cases, so this is a good thing. It means that my code doesn't work as I expected it to. So I caught a bug. Expected sunny was actually rainy. Did I mix it up? Probability of rain, probability of sun. The only one that did work was, oh come on, the one with 100% probability of rain, and this one didn't work. And now let's try to figure out why. I don't know why. To be honest, I thought that it was making sense, so it wasn't. Let's fix it. But probably the test itself is fine. Like, this makes sense to me. But the code, even with what you said, little logic, it failed. So there is even that little logic that needs to be tested. Probability of sun. That's obviously false. Oh, no, this is fine. What the hell? Zero. Right. So we generated 0, which is good. Probability of sun. So 100 minus 0 minus 100. Hey. Oh. Wait, what? Oh, okay. I see. Wait, no. Rain, sun. Huh. If rain is 100%, then this will be, this is 0, this is 100, this is 0, so it returns rainy. Okay, again, I'm a bit confused. Shows the code for building. I think you hard-coded some values. Oh, yes, okay. Thanks. Forgot to fix that. Thanks. Right. Okay, so that logic works. That's good. Now, if we want to be thorough, well, basically we tested it. And what do we notice? We notice that actually this is not needed at all. And, well, if that is not needed at all, then we can just do this. And if that one doesn't contribute to testability, then we can just remove that thing altogether. And since it is irrelevant what randomization does or how it works, we don't need the interface itself. It's overkill. And well, I do have randomizer under an interface. However, what it actually is, it's randomizer.instance. It's a singleton. I just added randomizer as a utility. a randomizer that is kind of static, because that's best practice, not to create too many randomizers, but also a randomizer that is something that I don't need to inject. Right now, it's still not enough because this part is not tested yet. I need to test this bit first. So the bit says if I need to test two things now. I need to test under what conditions I can create simulator and under what conditions it fails. And those two are quite different from one another semantically. Therefore, I need two facts for that. When possibility of weather exceed 100 throws, what does it throw? Invalid weather exception. Right, let's copy this. However, this bit is not needed. To make it simple, you need to be minimalistic. Exceeds 100, so this is 100, and this makes it one more, so minimalistic. And I need to verify if exception was thrown. Therefore, I say that this is an action for creating new weather simulator. And what I need to verify I don't remember syntax for it because I don't use this style. All right, assert throws the exception. Oops. Invalid weather simulation exception. And this is the action. Okay. And definitely, yes, constructor should be throwing exception because that is the earliest of how an invalid state can be picked up. If constructor wasn't throwing exceptions, then we would have way more invalid states. Here we have action, and we assert that it throws. Let's run it. It worked. Let's create one more test. And let's call it new when possibilities of weather under 100. Does not throw. Does not throw. Doesn't have that. That's quite sad. Throws. I think it doesn't. Okay, that's why I don't like this assertion framework. Action. Okay, var simulator. That's not true. You cannot feed a delegate into this method signature because it requires action. Local function is a delegate, but assertion requires you to pass a reference to a function, not the function itself. Let's try it. It won't work. Weather simulator throws nothing. There was that? Okay. Weather simulator create. Okay. It supports function as well. All right. Is this less code? I disagree. This is more code than the action. So I'd stick to this. We can actually compare, but this is less code. Yeah. Slightly less code. And it's more dumbed down because you don't really care what it returns, and I think it's more simple with action. Though that's good. That one works as well. But I've never seen anyone use it with local functions. All right. I'll just assert for not null, which is good enough. It doesn't matter. We use new features. I mean, I don't rely on any code. I rely on newest code. I see different things. But anyways, I think action is still better. Because it's dumbed down and it doesn't require you to think what it returns or to realize that you need anything else. This is universally applicable. Right. Also, if it did have parameters, and then you would need to, well, never mind. About that, it doesn't matter. Also, I didn't, of course, need to, I could have just said create and the return type would have been void. Yeah, that's true. It doesn't matter. It really doesn't matter. I think both action and local function are the same. Mm. Let me try again and see which one is more readable. Yeah, create is more readable overall. In this case, for sure. Yeah. It's actually quite a shocker to me because I do work with people who are experienced, who do use new stuff, but they don't try this. But I like it. Thanks. I appreciate showing that. It's a slight improvement. No need those ugly braces. Let me quickly see if the other one supports that. Well, mm, I won't use this one anyways when I'm working by myself because I use Fluent Assertion, BDD based assertion framework. So it goes like this. So I cannot, I need a delegate, so I cannot call a function. Yeah. Does it support that? Is there a way? Or should I just call it differently? I guess not. But yeah, that's a good thing to know. Thanks. Um, if we run this and if all succeeds, then that means that everything is well, and that component is fully tested. Right. This makes it exactly 100. It was kind of covered here. Um, Now, this test probably is a duplicate of this test. It doesn't really assert anything other than it succeeded. It's very explicit. And probably, maybe, you don't even need um, this one because it's already covered by the other sets. So for full testability, all that is needed now is just this and that. And if you look at, again, this thing, that's about it. That's all the logic that it had. I think that would be enough for this lesson because other examples would just show similar things. Now, about randomization, if let's say we had something that does depend on random, there are a few ways how we can escape that, and I'll just um, I'll just create a dummy uh, test that doesn't test anything and just show techniques how you can escape random. If you look at random itself, at the insights of the class, you'll notice one interesting thing is that all of its methods are virtual. It's virtual. And if it's virtual, that means actually that we don't even need to interface it. We can just inject it as is. And that allows us to mock it, to override the behavior. Let's create new random. Actually, let's create mock of random. And let me prove you that it can be mocked. Before this, let's create a mock of a hard-coded class, a hard-coded dependency, like our legacy email sender, and let's prove that it doesn't work. Send, doesn't matter what. And note how I write it is any, because I simply don't care what that it is. Just for test, for science. Now if I run this, I should get an exception saying that it's not virtual. Uh, Um, mm, 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 mm. Maybe I can mock it like this with empty stuff, but I'm certain that I cannot do setups. Though in this case, nor that it matters as well. This will for sure. Okay. And it says not supported exception, and it says unsupported expression on non-overridable members. Legacy cannot be used in setup. Legacy send method cannot be used in setup because it's not virtual. If I made it virtual, it'll work. However, that's a code smell because you don't want to have pieces of code that can be just changed at will. If you did write something, you want that to be set in stone more or less, because that makes the system more stable. Anyways, this is not mockable. Now, if I do the same for random, even though it's a class and not an interface, random mock. I should not. So the difference there is I don't want to change existing behavior, and I don't change behavior by properly inheriting. I just add something on top. That's proper inheritance. If I inherit and override something, that is also valid, but it needs to be really well justified and should not be abused. Because I have seen that happen, and I have seen systems that were really messed up by it. If something shouldn't be inherited, of course you should mark it as sealed, but changing existing stuff and inheritance are not really tightly related. Setup. I want to set up that my random next with anything returns 1, let's say. And let's say assert, well, let's say var number random mock object next. Let's pass it something crazy, like really 1% chance that the number would be that, if I'm that unlucky. And assert is equals I expect it to be 1, and it was actually a number. Now if we run the test, it succeeded. If we run it again, it will succeed again. So unless it was 1 in how much, 8 zeros in 100 million, unless it was 100 million, my test passes. I just proved that you can mock virtual methods, and I just proved that you don't need an interface for random. However, you can, and well, you can make your own random. boom. And I can say 1. And I can instead say, instead of all that mock, I say new my random. And it will behave exactly the same. Actually, it won't, because I did the wrong one. Yeah. Okay. Then of course I can just do the second one. So I'll just say how to escape random. I'll just split this into its own probably class for clarity's sake. This is fine. People repository. No, never mind. Okay. How to escape random. So overriding custom class. Let's get back my mock because I need it as well. Okay. And have it here. Right, let's call it mock random, override random, and last one would be adapt random. And that would mean that I just wrap it under the interface of iRandomizer, let's say. Okay. All right, that was a property. Okay. X black X next. Okay, great. And that's it. If I want to create that one, I say adapted random new random. Anyways, it's also different names. This is a mock, and this is no longer a mock, this is a stub, because it returns hard-coded values. did random did right? I probably also don't need to pass anything here because it's clear that, well, what's the benefit of passing some random? I can just hard code in this case. Because I anyways adapted. Right. Let's add facts so just that we can prove that it works in all those three cases. Well, in this case, all I want is to return 1, I guess. Whatever. For greenness sake, what's that? Right, for unsupported. Good. And that's it for this lesson. Do you have any more questions? To summarize, mocks make tests fast. Mocks allow us to escape dependencies that would otherwise be in our tests. Testability by itself is something you should strive for, but it shouldn't come as a thing of its own that would be completely different from what you normally do. It should come natural. Don't write code just so you can test it. Write code properly, and testability will come as a bonus. That's all. Thanks for your attention, and see you next time on Wednesday.